Alright, welcome to my first ever YouTube video on this channel. My name is Trent. I am a first year biochemistry major at the University of Cincinnati. So I am of course not licensed to teach anything at all, but here I am going to attempt it because, to be honest, I quite enjoy it. So yeah, classes I'm enrolled in right now are Chemistry 2, Biology 2, and then Calc 2. So I'll probably start off by covering topics that range across those classes. But I am willing to branch out and, maybe do some more fun / interesting math. But I figure what better way to start off than with the unit circle, because I feel like it's a pretty important topic of math in high school, and then, believe me, it doesn't go away. So yeah, I guess we'll just start by a general overview of the unit circle. So how the unit circle works is it's essentially a circle with a radius of 1, and you can kind of imagine it on like a XY axis, so this being the X, this being the Y. So as you can see, at the edge of our circle, we've got a radius of 1, -1, but still 1, and -1 again. So the way that I generally think of the unit circle is I tend to mostly stick in this quadrant, the first quadrant. I just have this one memorized, and then from there you can sort of logic it out if you need to. But I tend to see, at least in my experience with math thus far, I tend to see most of the time you're asked to solve certain trigonometric functions. I have tended to see them end up in this first quadrant, so pi over 3, pi over 4, pi over 6, 0, or pi over 2. So really, I just have this first section, this first quadrant memorized, and from there, if I need to, I can kind of build the unit circle by logicking my way through it. So at our first angle, pi over 6, we have root 3 over 2 as our x value and 1/2 as our y value. I guess I'll start at 0. So at 0, it's just 1 as our x value, 0 as our y. Then we already discussed pi over 6, so pi over 4 is pretty easy, root 2 over 2, and root 2 over 2 for both x and y values. And then we have, at pi over 3, we have 1/2 as our x value and root 3 over 2 as our y value. And then at pi over 2, it's just the opposite of 0, so it's 0 as our x value and 1 at our y value. So I just generally memorize this first quadrant as I, again, see it the most in my classes. And but you just basically add 1 each time. So as you go past pi over 2, the pi over 3s are going to be closer to your y-axis, and your pi over 6s are going to be closer to your x-axis. So you go past pi over 2, you get 2 pi over 3, and then, at this point, you're just on the opposite side of the y-axis. So your x values are all going to be negative. They'll be the same, like pi over 6, root 3 over 2. 5 pi over 6 is negative root 3 over 2, right? So they're the same. You'll just switch a positive or negative, and then that trend continues around the unit circle all the way till you get to 2 pi, which is 1 full rotation of the unit circle. Now, if you're in algebra, you might end up using these degrees, but since calculus only works in radians, if you're in a calc class, or really, I would assume any higher level math, you'll mostly stick to the radians. So like I said, the best way I find the easiest way for me to memorize the unit circle is to just know this first quadrant by heart, and then if necessary, you can kind of build around it. But a great way to practice whether or not you know your unit circle is by just simply listing out all of your different trigonometric functions and then solving them based off the unit circle. So we have sine, cosine, and tangent, and then we have cosecant, secant, and cotangent. So what value do we want to use? Let's say we can use we use pi over 6. So we want to use pi over 6 as our value. So our sine, we want to remember, is just our y value, and our cosine is just our x value. Now, these two are probably going to be the most important to remember because the rest of your trig functions are based off of these two functions alone, and these are how you can relate your trig functions to your unit circle. So remember, our sine is the y value, our cosine is the x value. So at pi over 6, we have a y value of 1/2. And at pi over 6, we have a x value of √3/2. Now, those two are the most important and, fortunately, the easiest. So when it comes to tangent, what we want to remember is that tangent is just sine over cosine, or y over x. So this then becomes 1/2 divided by √3/2. And when you divide by a fraction, it's the same as multiplying by the reciprocal. So we just have 1/2 times 2 over √3, which then equals, our 2's will cancel out. So now we're left with a 1 over √3 as our tangent. So now coming over to cosecant, what we need to remember is that cosecant is 1 over sine, which is just 1 over y. So that one's pretty simple too. It's just going to be the inverse of our y value. So cosecant is just going to be 2. And then our secant is just going to be 1 over cosine, or 1 over our x value. So just the inverse of our x value, which is going to be 2 over √3. And then our cotangent, again, is just derived from these two values. So our cotangent is just cosine over sine, which is just going to be x over y. So then we're plugging that in. We get √3/2 divided by 1/2, which is, again, you just multiply by the reciprocal. So you have √3/2 times 2 over 1, or just 2. So our 2's are going to cancel, and that leaves us with √3/1, or just √3. So if at any point in time you need to practice your unit circle or quiz yourself, I think this is the #1 way to do it, honestly. Aside from just getting a piece of paper and drawing out your unit circle, which takes a good bit of time. But yeah, like I said, through my experience, I've seen like 90% of the time, it's going to be one of these. You're going to have 0, pi over 6, pi over 4, pi over 3, or pi over 2 as the value that you need to use in your problem. So yeah, I just have those memorized, and then the rest you can just kind of logic your way through. But yeah, practice is key. Good first video. I hope to maybe make 1 or 2 a week. We'll see how that goes. Again, covering just a range of topics, whatever I feel like. But yeah, it'll be fun.